Good.
Hi, I'm Sabrina,
Not Juan.
and this is our final project. It's an LED spectrum analyzer, pretty much. And the reason behind our final project is we're both musicians and we really enjoy music, and we also really enjoy lights, LEDs, and stuff like that. So we thought it would be a good idea to drive LEDs with our Arduino to music to get an analog signal. So this is a really high-level black box diagram of our final project. So we have a power supply that is our LED strip is rated for 12 volts, but we had to turn it down. We realized that we had to turn it down because we were drawing way too much current for our LED strip. So we have 10 volts going to our LED strip, and we just get an audio signal. So right now we have it set like we have an iPod that picks up and it goes into a 10-pound amplifier because the iPod audio signal is in the millivolt range, and we needed it to get up to
About 3 volts.
about 3 volts because on our Arduino we have a 3.3 volt reference. And then we had it separated to a right and left channel, which you can see on the diagram. And then we fed it into 3 different filters. We have a high pass, low pass, and band pass. And we have those, you'll see later, our respective cutoff frequencies and things such. So we have blue corresponding to bass, green corresponding to our mids, and then reds corresponding to our highs. And we have identical filter networks for both right and left. And then we just feed that into a peak detector.
And then from the peak detector, from both the right and the left channels, they go into the Arduino, and it samples it at the peak instead of having the sine wave go. And then depending on the magnitude of the peak that we detect, it pulse width modulates, and then it applies that pulse width to a base of a NPN BJT. And then because the current that flows through the LEDs is too much for the microcontroller, the microcontroller only does 40 milliamps, or we need at least 50, or we need at least 500 milliamps for the LED strips. So we have it applying pulse width modulating to the base, and then tying the collector to the LED strip, and then the emitter to ground. So it runs through the BJT, and it doesn't affect the microcontroller. And then we have each of those outputting from the right and left channel to the LED strip, and then having it light up. And then these are our filters. Like the other display was the black box, and these are the actual filters that we use, including the gain calculations and the frequency cutoffs that we used to design it. In this case, we used the second order low pass filter in order to get a sharper cutoff, because otherwise it rolled off too slowly, and then we ended up with a lot of crossover between each of the bands. So we used an op amp for the gain portion. We chose R1 and R2 to be 16K, and then C1 and C2 we used the capacitors that came with our Arduino kit from the beginning of the year. And then we designed it to have a cutoff of 100 hertz for the low pass, and it rolls off and it cuts out pretty much by 300 hertz. And then we chose RA and RB to be 1 mega ohm, and then having them match the gain is defined by 1 plus RA over RB. Because they're matched, this ratio equals 1, so the gain is 2 for the entire low pass section. And then this one's significantly lower than the high pass or the band pass, because most music has thumping bass. It ended up being significantly brighter than the other one, so we ended up adding more gain to the other 2 sections.
Okay, so this is our high pass. For this one, we kind of had trouble implementing a second order high pass, so we ended up just using the first order, and pretty much the same thing. We chose instead of choosing a cutoff frequency at 20K, because that's like our max hearing, we chose 5.30K because most music doesn't reach that high, and 5.3K was already kind of. It was pretty high, so you can definitely see that in music. And then we chose, like Juan said, a higher gain because, especially with the high pass, so that you could. So you could actually see the lights. We tried a lower gain and it wasn't as bright as the blue.
And then for the band pass filter, it's already a second order filter, so we have 20 dB roll off on each side, and it's basically just a first order high-pass filter, a first order low-pass filter with an op-amp in between for the amplification. We chose both the high-pass filter and the low-pass filter to have the same cutoff, so that immediately at that cutoff it would roll off in either direction immediately. And that cutoff was 1.9 kilohertz for resistor values R1 and R2 of 820, and then the faster of 21 micro. And then for the gain, the green is visible, but it's overpowered by the blue just because of the nature of the color. So we had to put a higher gain, so we used an R4 value of 6.2 and an R3 value of 1 kilo ohm, and then we got a gain of about 6.2. And then each of those three filters on each channel goes into a peak detector, because the issue is music sine of a multitude of sine waves, and then if it goes negative, then the Arduino can't handle that. So we ended up just doing the diode rectifies only the positive signal, and then that charges the capacitor, and then we basically, the time console was designed to be 100 microseconds, so it doesn't decay fast enough so we can still sample the ADC and then not have it decay immediately. So we have 6 of these peak detectors, one for low, mids, and highs on each channel. And then the last circuit is the LED driver.
Yeah, so pretty much you have an amp, because you need voltage drops, I think 3 volt drops in between each color, RGB, which is on our strip, and pretty much we just pulse width modulated those so that, like Juan said earlier, that it would be a bigger pulse width as the intensity of the wave, or amplitude of the wave goes up. You guys want to come up and we're going to do it this demo?
It's the end of the
Do you want to test a right and left channel?
You got this sound?
That.
Wait, which one? And then also part of our demo, we're going to show how the left and right channel are different using a file or a music file that we found on YouTube. Well, it's not even music.
It's a guy just saying right channel, left channel.
Left channel, left channel, left channel, right channel, right channel, right channel, left channel, left channel, left channel.
Oh, the ground's
right channel,
coming in.
right channel, right channel, left channel,
There we go.
left channel, left channel, right channel, right channel, right channel, left channel, left channel, left channel, right channel, right channel, right channel, left channel, left channel, left channel, right channel, right channel, right channel, left channel, left channel, left channel, right channel, right channel, right channel, left channel, left channel, left channel, right channel, right channel, right channel, left channel, left.